All right, good morning again. So today we are going to go over lesson 1.4, which is translating verbal sentences into equations or inequalities. So in the last section, we did some translation of verbal expressions into algebraic expressions. But today we're going to be adding in some symbols, such as the equal sign and inequality signs, which will now make these something called an open sentence in math. An open sentence is a mathematical statement that contains two expressions and a symbol that compares them, whether that be an equal sign, then it's called an equation. So an equation is an open sentence that contains an equal sign. And an inequality is an open sentence that contains one of the following symbols here. So we have the less than or equal to, greater than or equal to. So, with that being said, when you substitute a number for a variable in an open sentence, the resulting statement is either true or false. If the statement is true, the number is a solution of the equation or a solution of the inequality. So, talking about those five symbols, just like we did yesterday in the other lesson where we talked about the different words that refer to different operations. Now we're going to talk about different words that associate the meanings of these different symbols. So now one thing that I always kind of think about is that the less than sign and the less than or equal to sign both face the direction of an L. So if you kind of think about the letter L and it's like slightly tilted, that would stand for L for less than. That's the way I remember it. And if it's facing the other direction, then when I'm reading it, I read it as a greater than. So we know the equal sign means is equal to, but other words we might see that infer that we're going to use an equal sign would be the same as. Another one here, we have that little less than sign. Looks kind of like that tilted L. And another word you might see to mean that is fewer than. Less than or equal to is the meaning, and then other words would be no more than or at most. And that can be a little tricky because when we see the words most or more than, we start thinking of things that are greater. But if it says at most, let's say it says, you can be at most 12 years old to order off the kids menu. Well, that means you have to be 12 or younger, right? So it's actually less than or equal to 12. But because we see the word most or more, we tend to just automatically in our brains think greater numbers. So that can be often confused. Then the next sign is a greater than sign. So if we have more than, then that would mean greater. Notice the last example was no more than. So that's where you have to be careful. Then the very last one is greater than or equal to. And here, just like we did with the other one, at least. At least means that's the smallest value allowed. So everything would be greater than or equal to that value. Or if you see the words no less than, then we know it's greater than because it's no less than. So that no kind of changes the meaning there as well. So writing equations and inequalities. So there's a couple types. So the first one we will look at here is going to be an equation. And the reason I know that is because I look through my sentence for the word is. Now, when you see the word is, that's a clue that this is going to be an open sentence with either an equal sign or an inequality sign, not just an algebraic expression. So once I see the word is, that's kind of like my dividing point. So if it's just a straight is, I know that's my equal sign. Now I look to the right of that here. The only thing I have is that 112, so I don't have to think too much about what to put on that side of the equal sign. But now all of this is going to make some sort of algebraic expression that's going to go on the left-hand side of the equal sign. So it says 8 times the quantity of 11 plus a number x. So that tells me that that part's going to be in parentheses. So 11 plus a number x in parentheses because it said the quantity of, and then I'm going to multiply that by 8. So 8 times the quantity 11 plus x is 112. Now, if we take a look at the next example, I'm looking for the word is again. Here it is. But then look immediately after that is. If there's any other words following it that could go with the is, then that tells you a little bit more about what kind of symbol is going to go in there. So in the last problem, after the word is, there was just that 112. So there was nothing else. It was just is. This one says is no more than. So if something is no more than 31, that means it has to be 31 or less than that. So this is a less than or equal to 31. And you can kind of use that little chart that we did in the beginning there if you're like not sure at first. So is no more than, if we look up here at our chart, no more than was a less than or equal to. Now, we already have our symbol. We have whatever's going to go on the right-hand side because there was just that 31. Now we need to figure out what this expression is here for the left-hand side. The product, remember from yesterday's lesson, that means multiplication of 7 and a number y. So 7 times y. And we know that when we do multiplication, we can just put the number and the variable right next to each other. We don't need to put a sign in the middle. You can, but it's really not necessary. All right, now the third one's a little bit different. And I'm not going to worry too much about these as far as the quiz is concerned coming up, but we will get into some more of these in a later chapter. But I might put something on there for extra credit, so it's worthwhile to pay attention anyways. So a number z is more than, so there's an inequality, 8 and at most 15. So this is a situation where we actually have two inequality signs. So this is kind of like a bonus part here. So if we're doing something like this, we have a number z is more than 8, and that number z is also at most 15, which if we look up on that chart, that's less than or equal to 15. So what they're giving us here is two different inequalities in the same sentence. Those can be very tricky and confusing. So if I put anything like that on the quiz, it would probably be extra credit. Okay, so now another way we can do these, which I think is much simpler, is when you notice that there's two inequalities in your sentence, all you need to do is figure out what is that variable expression. In this case, it's just z, and you put it in the middle. Then there's going to be two numbers there, two values. The smaller one, which obviously is 8, goes on the left. The bigger one, which is 15, goes on the right. It's always got to go from the smallest to the greatest, 100% of the time. If you set it up this way, they're always going to be pointing in the less than direction. So 8 is less than z, which is less than 15. And then the only tricky part is you got to figure out, do either of these get a little equal to line underneath? So if this was z is more than 8, well, we're not saying it's equal to 8, just more than 8. So that's good. Over here, at most 15 means it can equal 15 as well. So this would be a nice way to write that. When you have two different inequality signs, both relating the same expression to two different numbers, you put that expression in the middle, smaller number on the left, bigger number on the right. So a couple examples for that. So here we have the difference of 73 and a number x is 17. So again, straightforward, we have that is 17. So we know equals 17. Now we just have to figure out what is that algebraic expression for this part here. The difference indicates subtraction. So the difference of 73 and x, and then I'm just going to go in order, 73 minus x. 73 came first in my sentence, x came second, that's why I did 73 first, and then minus the x. Number 2, the product of 8 and the quantity of a number y plus 6 is less than. So the first thing I look for is, where is my symbol? Where is that equal sign or that inequality sign? Because sometimes a less than can mean subtraction. Sometimes it can indicate an inequality sign, but you have to look for that word is, and that's how you can decide which one. So first thing I do is I look for the word is, and then are there any words immediately following it? I know that this part is telling me it's my symbol. Is less than. There's my less than sign and my 21. Now I look at the rest of the problem, all of this part, and see if I can do my expression. The product of 8 and the quantity of, so I know whatever comes after that is going to be in parentheses, a number y plus 6. So we know that's in parentheses because it said the quantity of y plus 6. And the product of 8 and that quantity, so I have to multiply my 8 to that quantity. So these really just take a lot of practice. Everyone is always a little bit unique and they don't always follow the same exact maybe pattern. So it's kind of one of those things you just need to practice lots of different examples. Okay, so if we take a look at the next two. Number 3, again, first thing I do is look for the word is. The quotient of a number W and 5 is at most 4. So I'm going to fill in my symbol for that part, is at most 4. So that means that it can be equal to 4 and it can be less than 4. So is at most 4, right? So that means it can be 4 or 3 or 2 or 1 or whatever. So it has to be less than or equal to that 4. Now I can do my expression. The quotient, that means division, of a number W and 5. So W over 5. If you did the divide sign instead, that works, but in algebra, start getting used to writing division as a ratio. Number 4, the sum of a number Z and 2 is greater than 15. So there's my is greater than 15 and less than. So this is a double one. Remember, one of those double ones. So in this case, I've got 3 things. I've got my expression, the 15, and the 23. So the expression here, the sum of a number Z and 2 is going to go in the middle. 15 and 23 are going to go on the 2 sides. So which one's smaller? 15 is smaller. 23 is bigger. So it goes on the right. Then you don't even really have to worry about the words so much because they have to face that direction. They always have to point to the smaller number on the left and open to the bigger number on the right. Both of them have to face the same direction. The only thing you really need to read the words for now is to determine if there's any equal to lines underneath. Is greater than 15. Nope, does not indicate any equal to. And less than 23. Does not indicate anything that's saying it might equal it. So that's it. All right, number 5, the quotient of a number P and 12 is at least 30. So what does that mean? Is at least 30. If I said, my brother is at least 30, that would mean he is 30 or more. So greater than or equal to 30. Once you figure out that, now let's look at the expression. The quotient, which is division of a number P and 12, so it's just P over 12. Number 6, the sum of twice a number R and 3 is 11. There's no words following that is, so it's just going to be equals 11. And now we figure out our expression here. The sum, which is addition, right, of twice a number R and 3. So twice a number R would be 2R and 3. Those are the 2 things we are adding together or finding the sum of, and it should equal 11. All right, number 7, the quotient of a number N and 2 is at most 16. So that means it can be 16 or less. So less than or equal to 16. The quotient is division of a number N and 2. All right, and then number 8, a number q is at least 5 and less than. So this is another one with the two different signs. So a number q, that's my expression, that goes in the middle. 5 and 17. 5 is the smaller one, it goes on the left. 17 is the larger one, it goes on the right. Both of the inequalities are going to face pointing to the left, opening to the right. Is at least 5 indicates it could also equal 5. And less than 17 just means it's less than 17, not equal to. And that's how we would translate all of those verbal sentences. So now let's review how to check possible solution. You'll definitely have questions on your quiz about this. So check whether 5 is a solution of the equation or inequality. So when you're checking, all you're doing is substituting the number in. So we're checking 5. So we're going to substitute the 5 in. So we would write 3 times 5 minus 7 equals 12. So we simplify this part here on the left, and we want it to equal 12. 3 times 5 is 15. 15 minus 7 is 8. Clearly, 8 does not equal 12. So no, 5 is not a solution. 5 is not a solution. So we can try the same thing for an inequality. It's just that we're not going to only have one possible answer. Like the last one, you had to get 12 or it was not going to work. But this time it's an equality. So as long as the inequality is true or makes sense. So we're putting in the 5 again. Oops, I'm going to do it over here. 9 plus 2 times 5. And then 2 times 5 is 10. And 9 plus 10 is 19. So I end up with the statement here. 9 is less than or equal to 23, which of course is true. 19, or I said 9, I think, but 19 is less than 23. So that would be yes, 5 is a solution to this particular inequality. So let's check a few more of these. This time we're going to get specific numbers to check for. So that's what you see here after those semicolons. Those are the numbers that we're going to substitute in and check for. So if I'm doing number 9, I'm putting in a 4 here. 13 plus 4 is 17. 17 does equal 17, so that would be a yes. 4 is a solution. For number 10, we're going to put in the 2. 7 times 2 is 14. 14 minus 3 is 11. 11 does not equal 10, so no, 2 would not be a solution to that equation. Number 11, this is now an inequality, so I'm putting in the 3 for my variable. 4 times 3 is 12, and it's now saying 12 is less than 15, which is true. So yes, 3 is a solution to the inequality. For number 12, we have a 2 that we're substituting in. So 21 minus 6, which is 15. So I'm left with 15 is greater than or equal to 11, which is true. So yes, 2 is a solution to that inequality. 13, 4 times 3 plus 6. 12 plus 6 is 18, which is not less than or equal to 14. So no, 3 is not a solution to that inequality. And then 14 is one of those ones with the two different inequality signs. So we're putting the 6 in for the variable, which would be in the middle. And now I'm ending up with 6 plus 8 here, which gives me a 14 in the middle. So first of all, make sure the number you end up with in the middle is really in the middle or in between the number on the left and the right. So they should go in order from least to greatest, 7, 14, 15. Because these inequality signs are pointing to the smaller side and opening to the bigger. So 14 is greater than 7, 15 is greater than 14, so this one would be A. Yes, 6 is a solution to that inequality. All right, example 3, we're now going to solve a multi-step problem. In this example, we have a soccer team selling pizzas for $6 each. Each pizza costs $4 to make. The team has 10 players and they want to raise $900. So that's all the important information. Now, the first question says, how many pizzas does the team need to sell, obviously, to raise their $900? That's the first question. Then the second question is, how many pizzas will each player sell if each one has to sell the same number of pizzas? So before we even attempt to do anything with question number 2, let's just focus on question 1. How many pizzas does the team need to sell? So sometimes a good strategy is to kind of think about it in your head. A lot of times people can do it in their head. So then instead of trying to put the equation on the paper, think about in your head, like, well, what were you doing in your head, right? So you might be like, oh, well, I figured out that you're going to make $2 per pizza. Well, how did you do that? You took the amount you're selling each pizza for, you subtracted the cost that you need for the ingredients to make the pizza. That left you with the $2, right? Then you had to multiply that by however many pizzas you're going to sell, and hopefully that's going to give you a profit of $900. So here's the verbal model. It's already done for us in this particular situation. The price of the pizza, which would be $6, minus the cost to make it is 4. And most of you probably just did that step in your head, giving you $2 of profit per pizza. Then you're going to multiply that by the number of pizzas sold, which we don't know. That's what we're trying to find out. So that's our variable. And we're hoping that all of this gives us a profit of $900. So you can see, even though you could have probably done a lot of that in your head, if you have to write something on the paper and you're not sure how to do it, sometimes you might want to start just kind of talking yourself through it. So now we're going to solve this equation, which is just 2p equals 900. So I would just divide by 2, and p equals 450 pizzas, which is what we need to sell to make our profit of $900. So now we can go back and answer question 2, which said, well, how many pizzas will each player sell if everyone has to sell the same amount? So we know that we're going to have to sell a total of 450 pizzas, and we know there's 10 players on the team. So if we have 450 pizzas divided by the 10 players, we're splitting it evenly there. We're going to get 45 pizzas per player, which means each player will have to sell 45 pizzas so that they meet their quota. Okay, here's another example. Your family is driving 188 miles to visit a relative. Your father drives 53 miles and then stops. How many more miles are left? So first question here, I'm not going to even move on. I'm just going to focus on this first question. So how many more miles are left? Well, what do? You would take the total miles. You would subtract the miles driven, and that would figure out the miles you have left. So let's do that. We have 188 minus 63. So how many do we have left? So a simple quick calculation gives us 125. So now it says your father drives 50 miles per hour. How long will the remainder of the trip take? So this is question number 2. Now, to find the time, we're going to have to relate that to the rate and the distance. So if you remember that formula, distance equals rate times time. It can be kind of rearranged to get any variable you want by itself. So in this case, we're going to have to find the time, right? But we know that the distance that he has left to drive is 125. And the rate he was driving was given to us. It was 50 miles per hour. And then the time is t. So I can simply just solve this by getting the t by itself by dividing. And then 125 divided by 50 is 2.5. And of course, this would be hours. Since the rate was miles per hour, that means the time we're getting is in hours. Now, just a little reminder, sometimes they give you the time in hours and minutes, not 0.5 of an hour. So if that were to happen, it would be 2 hours and 30 minutes. So you would just have to take what's half or 0.5 of 60 minutes, and then you know it's 30. All right, and that's it for our lesson today on the verbal models.